Now that we know what to expect from the Lunar Reconnaissance Orbiter, we turn our attention to its sister payload, the Lunar Crater Observation and Sensing Satellite. Its goal is to hunt for evidence of water ice using a hard-hitting method. Dr. Kimberly Enico, LRO-LCROSS payload specialist, explains.
LRO-LCROSS mission has two impact events. The first is the upper stage of the launch vehicle that we take with us on our 4-month mission into space, and we separate from it, and it's traveling to hit the moon at 5,600 miles per hour. It's going to impact one of these lunar permanently shadowed basins of a crater on the lunar poles. And it's going to hit a particular place. It's going to hit a place on the moon that we think there's water. Scientists who believe that there is water on the moon don't know whether it's smooth or chunky peanut butter type. So where you hit is important. The secondary impact is the LRO-LCROSS payload, which will impact somewhere between 3 to 5 kilometers away from the first impact. So we're going to hit another part of that crater. We've targeted this crater because it's got a strong hydrogen concentration. We're going to sample 2 parts of this crater. And so the 2 impact events will tell us something about the distribution of this hydrogen concentration, or perhaps the distribution of water, if the hydrogen is in water. The live images of what we're taking with our science payload as we're going into the surface for the last 4 minutes of the mission, which is 600 kilometers down to the surface, will be streamed live on a public channel. LRO-LCROSS is important because it provides us a way to confirm the presence or absence of water ice at a particular location on the lunar pole. If there's water ice there, or water in some form, it means that for future missions to the moon, and perhaps beyond, there's an in situ, a resource that's there, a resource that's on the surface of that planet. You don't need to bring it with you. So for the human species, in terms of exploring the rest of the solar system, so getting out of low Earth orbit, and we need water with us, if we can find a resource of water on the moon, that will be an amazing step forward and a great resource to take advantage of in a very resource-limited place.
Both LRO and LRO-LCROSS need a successful launch in order to begin their missions. Our next guest is an integral part in getting these spacecraft and many others off the ground. Chuck Tatro is a mission manager in NASA's Launch Services Program at Kennedy Space Center. He's going to tell us about the unique challenges of this 2-for-1 launch.
Hello, my name is Chuck Tatro, and I'm a mission manager for NASA's Launch Service Program at Kennedy Space Center. We're at the Vertical Integration Facility on Cape Canaveral Air Force Station. This is where we will assemble the Atlas V rocket that will send the LRO and LRO-LCROSS spacecraft on their journey to the moon. As a mission manager, my job is to lead the effort to bring a new spacecraft and launch vehicle together to where they're ready to launch. About 3 months before launch, the spacecraft and the launch vehicle components arrive at the launch site for final testing. About 2 months before launch, the rocket components are erected on the mobile launch platform and filled with cryogenic fluids for a wet dress rehearsal. About 2 weeks before launch, the spacecraft is brought out here to the Vertical Integration Facility and stacked on the rocket. At about 1 week before launch, we do a launch countdown rehearsal so the team can practice for countdown. In a dual payload flow, both spacecraft have their own intricate and intimate requirements that are separate and may not play together nicely with the other spacecraft. For example, contamination, orbital requirements. Because LRO-LCROSS is going to impact the moon and LRO is going to go in orbit around the moon, we need to make sure that one doesn't adversely impact the other. The first challenge on this mission is the fact that the Centaur second stage will remain attached to the LRO-LCROSS spacecraft after it does its normal job of delivering LRO and LRO-LCROSS on their journey to the moon. LRO-LCROSS then will command the Centaur stage for an impact into the lunar surface. The second challenge is that the orbit requirements for each spacecraft are complex. This narrows the daily launch window that we have to launch this mission. The third challenge is that this is NASA's first step in our return to the moon, so there's a lot of public awareness and increased interest in this mission. We want to make sure that this mission is launched safely and successfully.
That's our show. To our guests, Kathy Petty, Dr. Kimberly Inico, and Chuck Tatro, thanks for giving us an insider's view of these two missions. We also thank all of you for joining us for today's webcast. Be sure to join us on launch day for the liftoff of the Atlas V rocket carrying the Lunar Reconnaissance Orbiter and the Lunar Crater Observation and Sensing Satellite. You can follow the countdown on NASA TV and on each mission's website at www.nasa.gov/LRO and www.nasa.gov/LCROSS. From Kennedy Space Center in Florida, I'm George Diller.